Hello, I'm Joe Hammaker. In this video, I'd like to talk to you about using SEER for space to estimate a constellation of satellites. Now, by my definition here today, a constellation of satellites is at least double-digit numbers of satellites up to possibly even several hundred. First, a little bit about me. I'm the Director of DoD and NASA programs at Gallup Federal. I formerly directed cost at NASA, and I have over 40 years of experience with cost estimating, chiefly using parametrics. My contact information is listed at the bottom of the screen here if you'd like to contact me. And anytime during this video, if you want to take a screenshot in Windows, you can press the Windows key plus Shift plus S and use the cursor to paint in what you need to make a copy of. Or on a Mac, use Shift, Command, and 3. As I said, I'll be talking about SEER for space today, which is the model described on the right-hand side of this screen. But first, let me make the point that SEER space is one of a suite of models that Gallup offers. SEER Sim is, start from the left here, SEER Sim is a software estimating model. SEER H estimates hardware and electronics. SEER for IT estimates information technology infrastructure. SEER for manufacturing does detailed production estimates of hardware, including the ability to go from CAD to cost. SEER Sys is a model devoted to estimating the cost of systems engineering. And SEER Space estimates spacecraft and spacecraft payloads, payloads being instruments, sensors, and that sort of thing. The first step in estimating a constellation of satellites with SEER Space is to set the platform knowledge base for our constellation mission. And you can see in the screenshot there that there are another number of other possibilities, but today we're going to use constellation mission. And what that does is it sets some of the knowledge base parameters for you in a way that's appropriate for estimating a constellation of satellites. We'll be setting other knowledge bases on a subsequent chart here. In this example, I'm assuming that I'm estimating a constellation of Earth orbital military communications satellites, and so I've set the application for that. I'm also assuming that the satellites that I'm estimating have a lot of heritage from some previous design, so I'm setting the heritage level at modification minor. I'm also assuming that these are Department of Defense satellites which require full military standards. That drives the amount of testing, the amount of documentation that's required, the number of reviews, and so forth. And finally, I'm setting the organization knowledge base, assuming that we have a prime contractor who is operating under a competing contract situation. Okay, the next step is to set the number of production quantity. Now notice in the top right-hand quadrant of this screenshot, I've got production quantity set at 1. Well, why have I done that when I'm talking about a constellation of satellites? Well, it's because I want the model to really give me a APUC, an average production unit cost, that's really a first unit cost. So if you look at the bottom left-hand quadrant of this screen, you'll see total APUC at $160.5 million. And because I've got the quantity set at 1, the model is really giving me that number as a theoretical first unit or T1 cost, first unit cost. And I'll explain why I'm doing that in a subsequent chart. So I set the production at 1 in order to make SEER Space give us an APUC that's really a first unit cost. If we were estimating just a few satellites, the learning curve in SEER Space does just fine. However, for large constellations, and here I've defined that, as I said earlier, to be double-digit numbers of satellites, up to hundreds, we want to take into account both learning and rate effects. I'll explain that on the next chart. So learning, you're probably familiar with. Learning is used to model cost behavior due to the total quantity produced. But there's another tool called rate effects, and that takes into account the cost behavior due to amortizing fixed costs, things like plant and equipment, over a quantity of units produced annually. So if you're producing more units on an annual basis, you have the advantage of amortizing tooling and plant and equipment over more units, and so that brings the cost down in addition to learning. So here today I'm going to talk about an adjunct SEER Space tool in the form of an Excel spreadsheet that we recommend you use for implementing both learning and rate effects. And that spreadsheet can be downloaded at the link at the bottom of this chart. And again, the instructions for doing that, for taking a screenshot of that, is at the bottom of the chart. If you don't get that, feel free to email me and I'll send you that link. Now let's take a look at that spreadsheet. First, at the top right-hand corner, this spreadsheet is based on a paper that's pretty old, about 30 years old. The spreadsheet is based on a 1991 paper by O. Douglas Moses, but I can assure you the math hasn't changed in the 30 years, so the math is still the same. But if you want to Google the title of that paper there, it'll come right up and you can see the equations and read about the technique yourself. So in this spreadsheet, which is depicted in the bottom right-hand corner, we need to make several inputs. First thing we need to do is make our first unit cost input in cell C17. And here I've just put that in as 100 units of money here today for illustrative purposes. The next thing we do is input the number of any prior production units in cell C18. Now it's fairly unusual to have a situation where you've got a restart of a learning curve after a prior production run, but if you do have that situation, you can model it with a spreadsheet by entering the number of prior production units in cell C18. The next thing is enter the annual quantities of units to be produced in each year, and that begins in cell C20. And notice here I've assumed 5 units per year over a period of 6 years. That's just a random assumption, for a total of 30 units. And so I've entered those in the spreadsheet as you see there. The next thing, we enter our learning curve and rate curve percentages in cells D20 through E20. And I've entered 95% learning and 90% rate. Now it'd be pretty unusual to change that and have that over time. Most of the time when you make a decision about learning curve percentages and rate percentages, they're pretty constant. And you can see here I've just left it 95 and 90 throughout the 6 years. By the way, 90% learning and 95% learning and 90% rate effect is in the sweet spot of what I normally assume when I'm doing estimates like this. Those percentages can really vary anywhere from 80 to 100%, but in today's example, I'm using 95% learning and 90% rate effects. Finally, we click on the Calculate Now button in the middle of the screen, and that produces our results. And there's a number of tabs that you can see at the bottom of the spreadsheet. We're only going to look at the first one here today, the Unit Learning Report, which the rest of them are redundant to that, graphics and so forth. So the tabular results of the learning rate calculation is shown here in the unit learning table. The first unit cost, or Unit 1's cost, is $78.2987 there, units of money. Remember, I entered 100 as our theoretical first unit. So unit number 1, taking into account both learning and rate, is 78.2987. You see that in cell D8. The second unit is 74.3837. Third unit, 72.185. And then you see the numbers continue to come down until we get to the 30th unit in this table in cell C11, which is 60.8761 units of money. Now, the average unit cost over all 30 of these units is 65.2572, is shown in the top right-hand corner of the unit learning unit cost table. And the total cost is in the top left-hand corner of the table for the 30 units is just shy of 2,000 units of money, 1957.7. Okay, so that's the gist of how to use SEER Space to estimate a constellation of satellites. So in summary, you select the platform knowledge base consistent with constellation mission. I recommend you set the production quantity to 1 and take into account, use the spreadsheet to take into account both learning and rate effects. And we found that the SEER Space model does pretty good on estimating constellations. We've estimated quite a few constellations for various customers over the past few years, and the model seems to be working well. So I'll repeat the first chart again with my contact information there at the bottom. If you have any comments or questions, or would like to know more about this, don't hesitate to contact me. Thank you very much.